Hey there, guys. Now that we have constructed the rule of the integral, I can go back now and actually prove that these derivative rules actually hold true. And another way that you can actually check that you took the derivative right. So, yeah, let's just like create an arbitrary f of x. Let's say, let's say, I don't know, let's say e to the x 5x or something like that. So we know that f prime of x is equal to e to the x 5. Actually, let's do it the opposite way. So we'll say e to the x 5x, or no, yeah, let's just do it this way. E to the x 5 and then plus 5x e to the x. So what do we expect here? That when we integrate this back, we will get our f of x. So what do we do here? We do a couple things. So this is going to be interesting. We're going to have to do some integration by parts plus, so yeah, this is going to be an actually interesting integral. So, hold on. What did we say? We said f of x is equal to e to the x 5x. So f prime of x is equal to e to the x times 5 plus 5x e to the x. So basically we want to take the integral of 5e to the x plus 5x e to the x. And by integration rules, we can split this up into two integrals. 5e to the x plus the integral of 5x e to the x. This obviously integrates directly. You know that the antiderivative of e to the x is e to the x, and this is just a constant, so it comes out, so it comes with it. So this is just 5e to the x. But now what we have to do is we have to focus on this guy. And for this guy, we're going to have to do integration by parts. So what are we going to have to do? Basically, we're going to have to say that u is equal to 5x, du is equal to 5 dx, dv is equal to e to the x, so v is equal to e to the x. So, and what do we get with that when we, let's do our integration by parts little formula. So we know that that will have to be equivalent to 5x times e to the x minus the integral of e to the x 5. So, okay, so that's basically we have to integrate that now, and we already integrated this, and we know that this will basically be equivalent to 5e to the x, negative 5e to the x. So when you write this, oh yeah, I see where this is going. That actually is interesting. Yeah, so basically what we have here, when we calculate the entire function out, we basically get 5e to the x minus 5e to the x plus e to the x 5x. So we get this, and obviously these two cancel, so this is what we end up with, e to the x to the 5x. So basically from our original function, it looks like we did it right, which is extremely good. So yeah, that proves that the product rule works when you do it correctly, because we took the derivative and then we integrated it and we got back to originally where we started. So yeah, that shows that the product rule works, and this is actually a way that you can check that your derivatives are actually correct, because if you actually integrate your derivative, you better get back to your original function. So yeah, that's going to be the end of this video. I'll catch you later, guys.